So on my driver's license, it says I'm Andrew Penland. I have a PhD in math from Texas A&M University in 2015. Right now, I'm an associate professor of mathematics at Western Carolina University, and I have I have research experience. I've written about 14 papers in mathematics on a variety of topics. But there's another piece of my background that's important to mention, and that's in the crypto space, I go by the name Octopus, and I really like to be called that when I'm not in my official role. I'm not a traditional mathematician in the sense that when I was a young person, I did not think I was good at math. It was a long journey for me to get here, and I struggle, still do, with academic structure due to neurodivergence, which is one reason I didn't go to university until later in life. But even before that, I was always interested in governance structures and alternative currencies. And I want to take a moment to remember the Asheville Liberty Dollar, which was the first alternative currency that I encountered, which was unfortunately raided in 2005. But it was a silver-based currency that was traded locally by members of the Asheville, North Carolina community and was accepted by about 100 businesses. So that was something I was experienced with before I had any idea that I liked math. I came to Rewards Systems. I started hanging around the TEC and TE Academy in January of this year. And I was really intrigued when I discovered it by this notion of praise. But I didn't even realize praise existed for about 5 months of my time in the Discord. I'm not sure how I missed it. Praise was a system that you may have heard something about, but basically users give praise to each other in a specific Discord channel or Telegram, and then that praise is quantified. So at regular intervals, it was every 2 weeks, I think, a team of 3 humans would meet and they would decide, okay, we have these things called impact hours that we're going to distribute. And based on their individual assessments and their discussions to bring their numbers into something of a consensus, they would then decide how many impact hours each praise should be rewarded, with the idea that later on there would be a token where impact hours would be converted to tokens for some impact hour holders. That's a simplification, but it gets to the nuts and bolts of the process that we're describing. I have this thing where I just randomly do things, and that's part of my personality. So I just randomly jumped into Discord meetings. That was just trying to find things that I thought were interesting. And basically at that time, my criterion for jumping into a meeting was if I saw that Sean Anderson was part of it, I jumped into it for sure. Because Sean is an outstanding data scientist. I learned a lot about data science and hacking from watching him lead these sessions. And one day I saw, it was Sunday afternoon, I remember, and that's not usually a time when I work. But I saw that Sean was in the Discord leading this session. And I thought, I'm going to jump in this to see if Sean is doing anything. And it turned out that that was fortuitous because I had jumped in at a very specific moment when a very important discussion was happening. There was a sense in the community among some members that the way that praise was allocated may not have been reflective of the way that the community actually valued contributions. And so this is a long discussion that I really can't do justice to. But in the TE community forums, this discussion went on. It went on in the Discord. It raised lots of interesting ideas. And the phase that they were at when I entered this meeting was wanting data analysis. So this was the perfect timing for me because my semester was just ending and I had some free time. And additionally, I teach data analytics skills, but I've never done that as an official job. And so I was thinking I should get some real world experience with this. So I have more credibility when I tell my students, hey, this is how data analytics works. And I also have a personality where I like to help people if I can. So I thought I'll do this data analytics and help these people with the answers to their questions. And I really had no idea what an adventure it would become. The first step was to really get into the praise process. So there's a video from where Griff and I discussed this. Griff, I want to praise him for walking me through the dynamics of the praise process, helping me get to a place where we could look at the data and understand how these numbers came into existence. And then the questions were like, if I want to tell people people had specific questions. And the question was, how can I, as a mathematician and data analyst, give calculations that will lead insight to these questions? And I had two tools that I thought I would be using because they were the two tools I knew. The first is the Gini coefficient. I had been to a workshop one time on mathematics and social justice that discussed economic inequalities. And their suggestion was that you use this calculus project about the Gini coefficient, not only to make calculus real to your students, but also to help them think about social inequality. And I'm not donating, not at the moment. No, don't send me an email reminder, please. All right. So the Gini coefficient is like a basic tool that economists use. And I'm hoping we can get to where it was calculated. So this is the basic idea. You have a distribution of income and you draw the curve where you're looking at what percentage of people control this percentage of resources. And if everyone had exactly equal resources, you would get a 45-degree line. And you compare that to the curve that you actually draw. And the difference between this curve and this line, roughly speaking, is the Gini coefficient, which is intended to measure how much, how unequal the resource distribution is. So the distance between this curve and a straight line tells us something. And it boils down to a single number that has a formula. And I thought, I will throw this at it, I will do the Gini coefficient, I will explain the Gini coefficient, and I will ride off into the sunset as a hero, return to my university, and have something I can put on my CV. The other tool I thought is, the Pareto distribution is an important idea. And I'm suspecting that the Pareto principle says that, roughly speaking, when we allocate resources, it tends to be that 80% of the people get 20% of the resources and vice versa. And I'm going to see that praise fits this, and it roughly did. And then that will be an insight that people will have, and that will be helpful. Well, it turns out I'm going to advocate against the use of these tools. And a few months after I did this analysis, Vitalik Buterin actually published a blog article called Against Overuse of the Gini Coefficient, which I think should be read by anyone who wants to do this kind of research or understand this. And the mismatch was pointed out to me by members of the TEC, which is that the Gini coefficient is intended for nation states, which is a particular structure. And a DAO or a crypto community is a very different kind of structure. So it may not be a good fit. It may not be appropriate to use tools that work or give insight at the global level on communities that are emerging and are smaller and have different dynamics. So I did what my academic training had prepared me to do, which was I went to the papers and I saw, well, what other tools have people used? And I discovered that there's been this idea called the Nakamoto coefficient, which is again a way of attempting to quantify the distribution of power or resources in a community. This looks at decentralization. So the Nakamoto coefficient is defined as the number of people, the number of individuals in the community that would be necessary that if they marshaled their resource, they would have more than 50%. And this is based on the idea that if you have 51% of cryptocurrency holders for a particular cryptocurrency, they may be able to vote against the system's interests. In cryptography, there's this idea of a 51% attack. So the Nakamoto coefficient is essentially the number of people you would need to mount a 51% attack on your system. And then another tool that academics have used to measure this is the idea of Shannon entropy. So Shannon entropy is about how things are distributed. Basically, if events are completely random, you have one extreme of Shannon entropy. And if events are constant, you have another extreme of Shannon entropy. And you have something between those two extremes, and the numbers give you some insight. I do not agree with this warning too easy unless it's intended in a positive sense. So there are some numbers that have been proposed in research of how you can measure resource distribution in a community. And some of those resources, particularly the Nakamoto coefficient, is intended as a crypto native metric. In Vitalik's blog post against the overuse of the Gini coefficient, he proposes some others. And if you look at this, it makes a difference whether you're looking at economic resources or voting resources, because those are two different types of resources. So there's a whole branch called voting theory that I think we as a cryptocurrency community would do well to try to delve into, because people have already thought about a lot about how votes are distributed in different kinds of decision-making processes. And some of what we're doing in talking to voting theorists seems like we're just like discarding huge piles of their work. But the big thing I want to say is I don't think any of these numbers or any number is going to do what we want it to do. This is not a hammer you can come in and break the glass and solve the problem. So this was actually a very humbling experience for me. I came in with some ideas about my own expertise in this space. And when I felt that I was offering expertise, it usually wasn't helpful. What was more helpful was when I asked more questions and engaged in conversation. I think that calculations will always be an important part of a community's sense-making process, but they cannot replace it. And I guess if I had one lesson from being an observer who gradually became a community member in the TEC during this time, I would say if you're consciously designing a reward system, try to think about what kind of disputes might emerge in the future. And so the tools and the framework that I'm going to try to offer in these last 5 minutes are towards thinking about that. So the first is that context is always going to be crucial. I don't think it would be fair to come into my family and say 50% of the people, the parents, control 100% of the economic resources, so this is an unjust system. The group of people are going to make their own decisions about what's fair and what's not. And the tools that are appropriate for the context are crucial. I also want to say I really admire the engineering work that's being done in this space. But I want to say we need tools from whatever your thing is, as much as we need tools from computer science and engineering. This is an incredible opportunity to engage in a conversation in a way that has never been done before, where all of these different people with all of these different types of brains can actually talk in a new way. And let's not waste that. I also want to say, if we're not careful, I think that DAOs risk replicating things that are big problems in the external society. And I think that these problems are intertwined. So there are major issues with what has happened to the presence of women in computer science. If you look at World War II, when the first mechanical computers were created, this is not the right chart, this is the right chart. In 1945, 100% of the people who used mechanical computers to actually do calculations were women. They were the code breakers at Bletchley Park, and that was it. 1945, 100% of computer programmers are women. By the time we get to 1993, 28% of people who are receiving bachelor's degrees in computer science are women, and that number has continued to drop. And for reasons that I don't understand, there's this inflection point at 2005 that's especially important perhaps, but this trend is really troubling. It's like a tragedy. Something happened. This wasn't a natural process. Something happened within the science of computer science, the Society of Computer Science, that drove women out. And we need to be sure, we need to look back at that and make sure that we do not do that in this space. The second thing is decentralization is not a new idea. In fact, it's almost like centralization is the new idea. So I want to plug a book called 2 Cheers for Anarchism. I didn't become interested in cryptocurrency to make US dollars. I was interested in decentralization. In fact, I would say I was part of decentralized autonomous organizations starting at about 2004, when I was part of a pirate radio collective and we worked together to broadcast over airwaves without a license. There's a cypherpunk movement that we could date back to the 1970s. In 2006, I was reading books that were talking about e-gold. This is part of an intellectual tradition. We're not just coming into this without a history. And I think we owe it to ourselves to learn this history. As tools we can use to guard against this, one thing I want to put a plug for is the rule of 4, which is the idea that when you have something you're looking at, you can try to look at it in 4 different ways. I think that doing this consciously, so graphically, numerically, words, and symbolically, this is an idea that I try to use in my classes when I'm doing mathematics education. But I also think it's important to recognize that it's going to be very easy for technical and symbolic expressions to overtake this discussion. And I think we need a framework at the beginning that prevents that from happening by saying each of these 4 ways of thinking are important. And let's make sure that we're doing all of them when we do this. I think it would be good if we came up with some benchmark examples. So in optimization research, when you propose a new algorithm, you have this suite of graphs or examples that you can run it against to see how it's working. I think if we as a community could come up with a variety of situations that DAOs have encountered or could encounter, that it would help us, because when we design new tools, we can then say, okay, well, how does this apply to this pattern that has already been observed? I'd like to advocate for doomsday planning. It's important to think for participants and all of us to think about what could be the worst thing that could happen. I want to acknowledge I learned this from Angela. 2 things that might be helpful from a computer science / software development perspective: user stories. Can you think about the type of people who are going to join your DAO? What will they want? What will their onboarding experience be like? What will make them feel valued? Finally, I would like to propose an idea, since we're moving towards a meta thing. Let's think about our metametrics. How will we measure, how will we know if a metric is accurately capturing whether or not what we want it to in terms of rewards distributions? And I don't have any good answers to this, so I apologize if you were expecting to be enlightened. But hopefully, in thinking about these questions together, we can work together towards getting what we want and distributing rewards in the way that we want. Thank you so much for your attention. I really appreciate it.
Thank you, Andrew. I realize that we have a lot of questions being raised in all the talks. Here's another one to chew on. Thanks, Andrew, for sharing your thoughts. And thanks everyone for being here. I realize that we have a lot of people here in the call for hours and also on YouTube. Thanks for being with us. For those of you who just joined, you can watch all the talks as recordings. We'll share them on our YouTube channel, Token Engineering. And yeah, feel free to drop your questions to the chat. We try to capture them in the talks.